Gauss lost the definition of E. And what's the proof for this claim? Like I have seen many different formulas from Gauss which have been proved using the definition of E and not other stuffs. Like for example, from the gamma function definition, gamma of x equals to integral from 0 to infinity e to the power minus t to the power x minus 1 dt. Yeah. Now, even in this formula, Gauss uses the definition of e for e to the power minus t. Yeah. And then use integration by parts, and he derives the new formula. Boom. And the new formula is limit n tends to infinity n to the power s by s product from k equals to 1 to n, and we have k by s plus k, and over here this is actually s not x. Yeah. So Gauss loves to derive formulas using the definition of E and get some pretty weird results, like this one for example. Gauss also derived this formula using definition of E, and let's see how did he do that. Yeah. Okay, basically he starts with the Hn, which is integral from 0 to 1 minus x to the power n by 1 minus x dx. Now he lets t to be 1 minus x. Yeah. And that gives us integral will go from 1 to 0, 1 minus, this is 1 minus t to the power n by t, and then minus dt. Yeah. And now minus sign will reflect the integral to go from 0 to 1, and this is 1 minus t to the power n by t dt. Now to use the definition of E, he should have a fraction over here. Yeah, a t should basically be let's say u by n, isn't it? So that he can later use the definition of E. Okay, so he does this, and now u equals to tn, and so du equals to n times dt, and the integral will go from 0 to when it's 1, 0 to n, 1 minus, note that this is all is as n, 1 minus u by n to the power n by u by n, and over here we have du by n. Now the n cancels out. Okay, and now we have Hn equals to integral from 0 to n of 1 minus u by n to the power n by u du. Okay, now after this basically like Gauss was trying to find an integral representation for gamma function, so OLM external constant. So that's why like how we can try to find ln u from this. So basically we can find, since here's 1 by u, we can find ln u. Yeah, and but it is also at 0, like it's also going from 0 to n, so ln of 0 will be minus infinity. So that's why like clever like change that we can make is to let it go from 0 to 1 first. Yeah, and then from 1 to infinity, or let's say 1 to n, and we can later make a limit where n goes to infinity. Yeah, and 1 by u du plus 1 to n. Yeah, not plus, we have minus 1 minus u by n to the power n by u du. Okay, so basically I divided the integral from 0 to 1 to 1 to n. Okay, so now this is just ln of n minus ln of 1, so that's just ln of n, and you can take ln n to other side. Yeah, and see like how cleverly he get the condition for the Euler-Masonry constant and also for the E over here. He's really good at making these manipulations. Yeah, minus integral from 1 to n 1 minus u by n to the power n by u du. Now he puts the limit n goes to infinity, and now there's the surprise. So we have Euler-Masonry constant over here, and over here we have 1 minus, this is just e to the power minus u, yeah, from the definition of e, and then du minus over here integral from 1 to infinity, yeah, and this is also e to the power minus u by u du, and we derive the formula. Basically, in our initial statement there's x, I guess, so we can replace u by x, and that gives us the integral representation of gamma function by, sorry, Euler-Masonry constant by Gauss. Okay, I wanted to write x, 1 minus e to the power minus x by x gx minus integral from 1 to infinity of e to the power minus x by x dx. Okay, so this is it. So basically from here I wanted to show that how like good manipulation does Gauss make. Yeah, he basically can find the LNU in middle of the NF integral, yeah, and take it to the side. He can also use the definition in like seemingly unobvious way. Yeah, so basically he can do a great job in maths. Hope you enjoyed the video. Look forward to seeing in the upcoming videos too. Thanks for watching.